Moving on to Unit 6. Okay, so Unit 6 was all about trig. So the first part of the unit was on the unit circle. And then the second part of the unit was all of the functions. Okay, so to answer the first question, it says the sine of angle theta is 0.2. What is the cosine of theta? So remember how if we were to make this right triangle, then there'd be a coordinate point at A. And what ends up happening is that the x coordinate of the point is the cosine of the angle. So that means this distance is the cosine of theta. And then the y coordinate in the point is the sine of the angle. And it says the sine of the angle is 0.2. So in a unit circle, know that the radius of the unit circle is 1, we can actually use the Pythagorean theorem. And that's why this is called the Pythagorean identity, because it stems from the Pythagorean theorem to figure out then the cosine of theta. So while I'm working this out, I usually replace this with an x because I know it's the x coordinate at that point. It's just easier to write. So these are the legs now of a right triangle, and so I know x squared plus 0.2 squared is equal to 1. And a lot of times, like, kids make mistakes here because everyone knows that 2 squared is 4, right? And so a really common mistake is to do 0.2 squared and call it 0.4. But look at that, it's 0.04. So just really be careful as you're working through problems like this, especially when you have to square decimals of familiar numbers. So it's 0.04. So x squared plus 0.04 is equal to 1. And so x squared is equal to 1 minus 0.04. 1 minus 0.04 is 0.96, which means x is the square root of 0.96. Okay? And the square root of 0.96 is an irrational number. So I'm just going to leave this in square root. But the last thing to do here for this problem is say, okay, now I know that distance. In that quadrant, is x a positive or a negative value? And in this quadrant, x's are positive, right? Because here's 0, so you have to go over to the right. And so that means the cosine of theta, the number we just found, is the square root of 0.96. You want to make sure you give your final answer in that manner, okay? Because that's what it was asking for. It was asking for what's the cosine of theta. The next one's really similar. This time we're given the cosine of the angle. So again, here's our right triangle. Take it down to point P. And so even though the angle is all of this, this is the right triangle we can use to figure it out because that's where the point is. Okay? And so it tells us the cosine of angle theta is 0.2. So this x distance is 0.2. Now we're trying to find the sine of theta. And again, that's going to be the y value in the coordinate. So I'm going to use a y in the equation, just it's left to right. So 0.2 squared plus y squared is equal to 1. So I already know it's going to be, the square root of 0.96. I'm going to not rewrite all of this and just jump to that. Y is equal to the square root of 0.96. So when I give my answer as the sine of theta, I have to remember, oh, y is negative in this down here, right? We're below the x-axis where y is negative. So it's negative square root of 0.96. Final answer there. Okay, moving on to the next page. We're looking at some angles. What angles are represented by the same point on the unit circle as 2 pi over 3, also known as 2/3 of pi. Okay, so first of all, any angle that's going to land in the same place definitely has to have the same denominator in the fraction, right? So you could use your unit circle for this, but I'm actually just going to draw a circle and think of it, right? Here's 0, here's pi. If we split the top into 3, then right here is 2/3 of pi, or 2 pi over 3. So this is the intended angle to land at, right? And I'm going to go ahead and split the bottom also into thirds. You can see what a circle looks like when it's every angle is just 1/3 of pi, or pi over 3. Okay, so -4/3 pi. So starting here, going backwards by 4. 1, 2, 3, 4. That's where we landed, so this is a yes. Okay, 8 pi over 3. 1, so this is going to go counterclockwise because it's a positive angle. So starting here, 1, 2, 3, 4, 5, 6, 7, 8. Landed, so yes, B is also an answer choice. What about 14 pi over 3? So we landed here at 8. So I'm just going to continue counting from here. This was 8, 9, 10, 11, 12, 13, 14. We landed there again. C is also a correct answer choice. Next one, pi over 3. So starting here, just going one place. That doesn't land there. Okay, so no. Next one, -2/3 pi. So we're going to go clockwise. 1, 2. We did not get there. That is a no. And then finally, -8 pi over 3. Starting here, going clockwise. 1, 2, 3, 4, 5, 6, 7, 8. We also did not land there, so that one's also a no. All right, and then finally, for this part, before we get to the equations, a rotation takes P to Q. So from right here to right here. What could the measure of the angle of rotation be in radians? So I know this is 0 and this is pi. So and this quadrant has just been split right in half. So if we also split this side in half, I can see this is 1, 2, 3 fourths of pi, right? Because now it's been split. Pi has been split into 4 parts. So one positive angle would be 3/4 of pi, or 3 pi over 4. And then if we just go around the circle further, so we've already gone 3/4. And then, I'll split the bottom in half as well, so that we're like traveling by, okay, so pretend those are exactly in half. So we're traveling by like equal increments. So this was 3/4 of pi, 5/4, 6/4, 7/4, 8/4, 9, 10, 11, 12. Wait, does that work? Hold on, I have to count those again. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I knew it wasn't right. So 11 fourths of pi, or 11 pi over 4. They mean the same thing. Okay, you could keep going. Every time you're basically adding 8 to the numerator, you might notice that here, because we split the circle into 8 parts. All right, next is the negative angle. Change colors for that. So again, we always start here at 0. And so it's 1, 2, 3, 4, 5 of those sections. And each section is fourth of pi. So -5/4 of pi, or -5 pi over 4. And then we could keep going. 6, 7, 8, 9, 10, 11, 12, 13. And let me just double check that I got them all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 in the negative direction, negative 13 fourths of pi, or negative 13 pi over 4. Okay, and then we got into some trig functions. So let's do this real quick. For each of the following, name the amplitude, midline, and period. For those of you that are in my classes, you were really good at amplitude, midline, and then we're a little shaky on the period, but that's okay. We'll figure it out right now. So I highlighted them just to think about, like, as we're looking at equations, amplitude is what's being multiplied by, to the either cosine or sine of the angle. And so there's not anything here, so that has an amplitude of 1. I'm just going to go through the amplitudes first. Here, cosine is being multiplied by 4, so it has an amplitude of 4. This also has an amplitude of 4. And then, I know it's negative, but the amplitude is really 2. It just also has a reflection. Here, the amplitude is 12. And then here, the amplitude is m. So for amplitude, we have 1, and then 4, and then 4, 2, 12, and this funny one, m. Okay, so that's amplitude. Next is midline. So the midline is like the shift up or down. So this has a midline at y equals negative 2. This one, y equals 8, y equals negative 6, y equals 1, y equals negative 18, and y equals negative c. I'm going to write those down. Y equals negative 2, y equals 8, y equals negative 6, y equals 1, y equals negative 18, and y equals negative c. Okay, the final is the period, and the period comes from analyzing what's happening to the input, okay? So on B, notice that this is just theta. There's nothing multiplied by anything. And so that means the period for this one is just 2 pi. And that's like our, that's our parent function also has a period of 2 pi. So anytime that there's anything else being multiplied by the angles being multiplied or divided by, we can talk about both of those. We have to adjust the period of 2 pi. So in A, I'm going to write down period equals. So see how we have 3 times theta, not just theta? So it's 2 pi divided by 3. And because 3 doesn't divide evenly, I'm just going to leave it like that. Here, this one gets a little tricky because it's x divided by 5. And you have to remember, like, this is the same thing as 1/5 of x, or 1/5 times x. So that means the period is equal to 2 pi divided by 1/5. And when you divide by a fraction, you just multiply by the reciprocal. 2/5, or 2 pi divided by 1/5 would be times 5 over 1, which is just 5. So this one has a period of 10 pi. Okay, down here we have our variable n is being multiplied by 4 pi. So the period is equal to 2 pi divided by 4 pi. The pi's divide out, and this is just 1/2. Okay, this pi over 2 times x. Okay, so then our period is equal to 2 pi divided by pi over 2. Again, we change divide to times, and multiplied by the reciprocal. So this is like an over 1. So here the pi's divide out. 2 times 2 is 4. So this has a period of just 4. And then in the last one, this one's kind of funny because it's like x divided by b, which be the same thing as 1 over b times x. And so to calculate the period, it's 2 pi divided by 1 over b, which means 2 pi times b over 1, which is 2 pi b. That's how that works. Okay, and then finally, we have to write an equation of a function that has this graph. So we want to figure out all of those things first. So what I like to do to find the midline is I look at, well, where's the top of the graph? Where's the bottom of the graph? And then this is at 1, this is at 7, and so the middle of 1 and 7 is 4. So here's the midline. Okay, and also the amplitude is 3 because from 4 to 1, that's a distance of 3. And from 4, let's see here, yeah, from 4 up to 7, that's also a distance of 3. So that's our amplitude. Okay, so we have the midline, we have the amplitude. So we have y equals 4, and then the amplitude equals 3. And then I'm going to look at the y-axis. Here's the y-axis. There's a maximum point here. So because that's a maximum point, I can write this as a cosine function without a horizontal shift. So I'm going to use cosine. And then the last thing I have to do is figure out, well, what's the period? So the period starts high, ends high, right? And then this, oh, I want to use a different color. Sorry. This from 0 to pi, that tells me that the period is equal to pi. Okay, so we have to put all of those things together in an equation. I'm just going to use y and x because that looks easiest to use. So y equals, the amplitude is 3. I'm using cosine. And I can't just put x because the period isn't 2 pi. So to figure out what goes here, it's you just kind of do the same thing as the reverse process. It's just 2 pi divided by the period. 2 pi divided by pi is 2. So rather than having just x here, I'm going to put in 2x so that we get the correct period of just pi. And then the amplitude, or sorry, the midline is 4, so plus 4. All right, and that's how you write the equation for that graph. All right, that is the end of the Unit 6 problem. So again, happy studying.